All right, so this part of the lecture is classifying matter, so basically able to separate matter into different parts. So you can kind of see from this that we can separate matter into two things, mixtures or pure substances, based off if we can physically separate. So we're going to go down the mixture route first. So we'll go in this way. So let's say you can physically separate. And then so mixtures, there's two types. There's homogeneous and heterogeneous. And then within heterogeneous, you can have colloids or suspensions. All right, so mixtures, homogeneous versus heterogeneous. So homogeneous, the prefix homo is the same, right? So this is a mixture that looks the same throughout. So it's uniform throughout. So like this, that is a homogeneous mixture. So let me do it in a different color. So this one right here, that's homogeneous, meaning it's green throughout, right? And so we'll call that a homogeneous mixture. We also call them solutions, right? And then heterogeneous, so the term hetero, or the prefix hetero, means different. And so it's not blended or smoothly, not blended throughout. So like you can actually see different parts. So here's an example of a heterogeneous. This is heterogeneous because you can see the individual parts. Here, this could be like salt water, right? Which would be, this would be homogeneous because you can't tell the different parts. All right. Now, homogeneous homogeneous mixtures cannot be called solutions, but but heterogeneous, actually, you can mix into two different categories, or you can change into two different categories. One is called suspensions, and that's where you have larger particles that settle out over time, so it's really easy to tell. And so here's an example of a suspension. Here you can see, like, I'm guessing this is probably water and oil, so you can definitely see here's the oil and here's the water. So you'd say that the oil is suspended in water. And then the other one is colloid. So a colloid is the same as, but they have smaller sized particles. So even though like milk here is an example of a colloid. Now some people might look at milk and be like, hey, that is supposed to be a that looks like, you look at milk and you think that's a homogeneous mixture, but milk actually isn't homogeneous, it's heterogeneous. It has different parts. Those parts are just a little too small to see. So how can we tell the difference between, say, a colloid, which is a heterogeneous mixture, and a solution, which is a homogeneous mixture? How do we figure out the difference? Well, the answer is we use what's called the Tyndall Effect. And so what happens is if you flash a laser or a light in a solution, so remember a solution is a homogeneous mixture, light doesn't scatter, it just absorbs the light. But in a colloid or a suspension, remember these are both heterogeneous. What happens is the light scatters. And it scatters because it actually hits the different solutes, the particles that are in the solution or in the mixture, and what it does is it kind of bounces off, and so you get this broad band of light. So how can we tell if it's homogeneous or heterogeneous, especially when the naked eye can't see exactly if it's a colloid or a solution? Well, we just can flash light or a laser or some type of beam into the solution or into the mixture. If it is absorbed, it is a solution or a homogeneous mixture. If it is scattered, we know it's heterogeneous, either as a colloid or a suspension. All right. So now that we talk about mixtures, we know that there's heterogeneous, homogeneous mixtures. Within the heterogeneous mixtures, we have colloids and suspensions. Let's talk about how we can separate them. So there are four techniques we're going to talk about: filtration, distillation, crystallization, and chromatography. So in filtration, it's just kind of like if you ever make coffee in the morning, you have that coffee filter paper, and the filter paper keeps the grounds right out of the coffee, so the water runs through. So if you have a mixture of, some type of solid and liquid, oftentimes filter paper, because they have the small holes in them, can actually separate the solid from the liquid. So that's filtration. So you use a filter paper, and filter paper has different size holes in them. This one's called distillation. I put a video because distillation is kind of hard to understand sometimes. Basically, what happens is, let's just say, for example, so distillation, the biggest thing is you use the boiling point of the substances to separate the material. So let's say you have a solution, and let's just say in this solution you had, here I'll do it up here. Let's say you had water, which boils at 100 degrees Celsius, and you had, I don't know, say ethanol, which is an alcohol, which was, I'm not too sure, but each boils, let's say, at 50 degrees Celsius. So what happens is, as you heat this up, as you heat up the solution or the mixture here, well, what's going to boil off first? Well, the ethanol will boil off first. So what will happen is, if you, say, heat this and it's at 75 degrees, the ethanol is boiling off and it gets trapped into here, right? But the water hasn't started boiling yet, so it stays as a liquid down here. And so it's a way to separate mixtures here. Okay? Or separate substances, I should say. You can also do it by crystallization. So sometimes if you have like solid particles that are in a liquid, you can actually add more of those solid particles, and what happens is, as the time it gets what we call supersaturated or very saturated, and what you can form sometimes are crystals, and that's a way of removing or separating the solid particles from the solution or the liquid. And then lastly, chromatography. So chromatography is using, like we talked about, capillary action in a lot of cases, where you can separate like dyes, different colors. So here you can see, if you have a solution, you can separate the different particles as they run up, and you can separate them by like the distance in which they run. So this particular particle ran that far, and you can start to see them separate by color here. So you see this color is different than that. So you can actually remove these particles from the mixture. All right, so we've covered a couple things. So we've covered this side. So we've covered what is a mixture. We've covered the two types of mixtures. Homogeneous, also known as a solution, is where it's uniform. You can't tell the difference. Heterogeneous is when you can see a difference, or there is a difference. And so the two types are colloids, which are small particles, and suspensions, which you can definitely see. Those are larger particles in the mixture. So let's go down this route. And let's talk about pure substances. So there's only two types of pure substances. One is compounds, and one is elements. So an element is a pure substance that cannot be separated into a simpler substance, and elements are found on the periodic table. So here we have an example of elements. Notice they're all the same, and so these are elements. And a compound is a combination of two or more different elements bonded chemically. And so here's an example of a compound. Notice that here we have two pink bonded or connected to the green. And so that's what makes it a compound. And then the other part I want to mention was these are mixtures. So notice here we have multiple, like you have the two pink and then the green. So these are multiple compounds that are mixed together. Here you see two elements that are mixed together. Here are elements that are mixed together. And here's elements that are mixed together. And then lastly, just as a quick check, if you look at these two are mixtures, but can you figure out which one's homogeneous and which one is heterogeneous? So the homogeneous one is this one because look, they're mixed uniformly. So this is homogeneous or homogeneous. This is hetero because look, you can see there's a separation. So you clearly have one compound on this side and one compound on this side. So this is heterogeneous. Alright. I've posted a practice quiz or quizzes practice online, and also you have homework with the GPB 202.